All right, Foundations Pre-Calc 10, let's get after it. Here we go. We are writing equations of lines. Now you're going to see this all comes down to what information we have and the versatility of the different equations that we know. So, write in general form. So we're going to want to have an equation that looks like this in the end. A line parallel to this line. So remember that parallel lines have the same slope. So we're getting information from what we need. And then our new line goes through this point. Okay, so we can use point slope form. We could also use slope intercept form, but it involves solving a different piece of information. So we can use point slope form, but we need the slope. And since we know it's the same slope as this one, let's convert this into slope intercept form to get the slope that we're going to use. So negative 2y equals negative 3x plus 6. Divide by negative 2, divide by negative 2, divide by negative 2. This is all I care about. So the slope of that line is 3 over 2, which means the slope of my line is going to also be 3 over 2. And then I have the point 4 comma negative 2. So remember, I'm going to now use point slope form. So y minus y1 equals m times x minus x1. And I'm going to plug in. So y minus negative 2 equals 3 over 2 x minus 4. Now I'm just going to solve through. So y plus 2 equals 3 over 2x. Multiply that in here and here. The 2 cancels with the 4, so minus 6. I will now subtract 2 from both sides and get it into slope intercept form. Y equals 3 over 2x minus 8. For general form, no fractions. So now I'm going to multiply. So if we were stopping at slope intercept form, we would stop here. But for general form, I'm going to need to multiply everything by 2. So now I have 2y equals 3x minus 16. And for general form, everything on the same side. My x value is positive here, so let's just subtract 2y from both sides. So what I end up with is 3x minus 2y minus 16 equals 0. So there is my general form. So I had to take a bunch of different pieces of information, right? The slope from this line, the point from here. I had to convert to slope intercept form here first. I then needed to use that information in point slope form to get myself into general form. So we're kind of mixing everything into one pot and using it as we need to. So let's do another one. Now in this case, we have a line perpendicular. So remember, we're looking to the negative reciprocal of the slope of this line. So let's do the algebra here. Subtract 4x, subtract 4x. So now 2y equals negative 4x plus 7. And then divide by 2, divide by 2, divide by 2. So the slope of this line is negative 2. Don't even care about the y-intercept. This is all I care about. So the slope I'm going to use, in this case, since we're perpendicular, is the negative reciprocal of 2, which is positive 1 over 2. So my slope is going to be a half. The point I'm going to use is the negative 2 comma 5. So now again, I'm using point slope form. Y minus y1 equals m times x minus x1. So y minus 5, y minus 5 equals 1/2 times x minus negative 2, so x plus 2. Again, I'm going to multiply that in. So y minus 5 equals 1/2 x plus 1. And now I just got to do my algebra to get to general form. So everything's going to be on the same side, so let's do this. Let's go plus y plus 5 and plus y plus 5. Because now everything's on the same side. I have 0 equals 1/2 x plus y plus 6. But obviously, I do not want fractions, so multiply everything by 2. And this is why 0 is so handy, because yeah, I definitely have to multiply this by 2, but 0 times 2 is still just 0. So now I have x plus 2y plus 12. And again, the 0 can be on the left or right. Here I am in general form, but it's exactly the same as writing it in general form like that. So please do not freak out. So that's how we use our given information. Now, what if we're only given 2 points? Well, we can't use any of the equations we have yet because we have slope intercept form, we have point slope form. So we need the slope, right? Because we can't throw anything into standard form. It just doesn't work. So we have 2 points though. So remember our slope equation, y2 minus y1 over x2 minus x1, our change in height over our change in length of any 2 points. So my slope, I'm going to use 5 minus 2 over negative 3 minus 7. So this is my point 2, this is my point 1. So what do I get for my slope? I get 3 over negative 10, which means I get a slope of negative 3 over 10. So that's my slope. So now I have a slope, so I can use slope-intercept form, or I can use point-slope form. It doesn't matter which one you use. I'm going to use point-slope just because I don't like having to solve for my y-intercept after the fact. So let's use this one. And you can pick either point. I'm going to pick negative 3 over 5, but it doesn't matter, or not negative 3 comma 5. You can use either one. So now I have y minus 5 equals negative 3 over 10 times x minus negative 3, so x plus 3. So now we have y minus 5, and then multiply in, equals negative 3 over 10x minus 9 over 10. So the good news is here we're going to standard form and we don't want fractions, and you can see we have fractions. So let's just get rid of those now. We'll multiply everything by 10. That'll get rid of those fractions right off the bat. So now we have 10y minus 50 equals negative 3x minus 9. And we want x and y's on one side, and since my x's are negative here, I'm going to get rid of those first. So I'm going to go plus 3x on that side, plus 3x on that side, and then at the same time I'm going to go plus 50 and plus 50, because that gets rid of the 50 from that side, and it gets rid of the 3x from that side. And I end up finished. I have 3x plus 10y equals 41. Boom. So I've converted from point slope all the way into standard, and I got the equation of a line given only 2 points it passes through. So look at me go. Here's another example. And this time I'm going to write it in slope-intercept form. So I'm actually just going to use slope-intercept form instead of point slope. So watch here. I'm still going to do my slope equation. This is my point 2. And again, it doesn't matter which is which as long as you're consistent. So 9 minus negative 4 over 3 minus 1. Remember, I'm using my slope equation. My change in y values, change in height, over my change in x values, change in length. And what I end up with here is I end up with 13 over 2. So there's my slope. So now I'm going to use slope-intercept form because I have y equals mx plus b, right? Which means I have y equals 13 over 2 times x plus b. Now, why did I use this equation? Well, because I need my answer to be in this equation anyways. And just like point slope form, you can sub in a point. Well, remember that this xy is also any point. And I have 2 points. So pick a point and sub it in. So I'm going to use 1, negative 4 this time just to mix things up. So negative 4 equals 13 over 2 times 1 plus b, because you see we still need to solve for our y-intercept here. And what we get is we get negative 4 equals 13 over 2 plus b. I need to isolate b, so minus 13 over 2 and minus 13 over 2. So what do we have? We have negative 13 over 2 minus 4 equals b. So again, what's 4? It's 4 over 1. I need it as a denominator of 2, so equivalent fraction. 4 is equal to 8 over 2. So that means b is equal to negative 21 over 2. And now we have y equals, we don't plug anything in for x or y anymore, right? But we have our slope, x, and then we have our y-intercept. So we are done. You could use point slope form too. There is variety. Remember, I think there's some examples in the notes, but mix it up and just get comfortable with as much as you can. So this is our last one. And this just changes the information to make you think a little bit more. So write the general form equation. So, okay, ax plus by plus c equals 0 of a line that goes through this point, okay, and has an x-intercept of 7. Okay, so you might be looking at this going, okay, well, I don't have a slope. I only have 1 point. But you don't have 1 point. You have 2 points. The thing is, you just have 1 point disguised right here, the x-intercept. If a line goes through at 7 on the x-intercept, right, whatever the line looks like, What is the value of that coordinate? It's 7, 0. So there you go. You have 2 points. So let's call this point 2, we'll call this point 1, and we'll do our slope equation. So 0 minus 8 over 7 minus 3 gives us negative 8 over 4, gives us a slope of negative 2. So now we can use point slope, and let's use this one just because it's nice to have a 0 because it's just less work. So y minus y1 equals m times x minus x1. So y minus 0, oh how nice, equals negative 2 times x minus 7. So now y equals negative 2x plus 14. The nice thing with this example is we don't have any fractions we have to worry about. All we need to do is get to general form, which means everything on the same side of the equation. The other thing is my x term needs to be positive, and here it's negative. So rather than just subtract the y from both sides, I'm going to do subtract or add 2x and subtract 14 to both sides, because that way I end up with my positive x value. So boom, boom. So now I have 2x plus 1y minus 14 equals 0. Woo, yes, look at me. Look at you. We're done. So this is section 3.3. So you got a whole variety of shorts here for section 3. You have the entirety full lessons for section 3, and you have all the notes and workbooks included as well. So world is your oyster. Learn as best you can. And any questions or comments, please leave them in the comment section and I'll address them as best I can. Okay, keep it up. You're doing awesome.